Good morning, teachers and students. Thank you so much for joining us for our Monday morning live stream. Please stay tuned. We'll get started here in just a few more minutes. Please stay tuned.
Hello, everyone. I'm Congresswoman Deb Holland, and I'm honored to share a few words during this year's Discovery Festival. The sixth annual Discovery Festival, hosted by Big Brothers Big Sisters, has become a wonderful tradition, providing a wide array of opportunities for New Mexico students to discover the future of STEM. New Mexico is home to many historic and consequential scientific breakthroughs, discoveries that range from revolutionizing the way we'll power the cities of the future to expanding our ability to explore the cosmos. This year, for the first time, Big Brothers Big Sisters of Central New Mexico is hosting Discovery Fest virtually. I'm amazed at how many events and presentations this team has put together under such challenges this year, and I'm delighted to see that a record number of New Mexico students will join the fun and the learning of Discovery Fest. New Mexico is an amazing home for technology, and our kids are in a great position to learn more and take advantage of our state's unique and important role in the national tech space. In Congress, I support expanding STEM. Opportunities like Discovery Fest and fighting for resources for your incredible teachers because I know how important science, technology, engineering, and math will be for our future. I want to let you all know about my annual Congressional App Challenge that invites students to come up with one of a kind apps and have their app displayed at the national level. Students learn to code, manage a project, and learn more about technology. In that spirit, I'm thrilled to welcome this future generation of innovators, inventors, and explorers, and all the incredible teachers developing these bright young minds to this year's event. Our beautiful state of New Mexico, America, and frankly, our whole world's future will be counting on the creativity and innovative spirit of you young people. So I want to encourage all the future physicists, researchers, biologists, and engineers watching right now to keep reaching for the stars. Learn all you can, and most of all, have fun at this year's Discovery Fest. Thank you.
Great. Thank you so much, Congresswoman Deb Holland, for those wonderful words of support. Good morning and happy Monday. My name is Will Toppy, and I'm the Advancement Coordinator for Big Brothers Big Sisters of Central New Mexico. And as Congresswoman Deb Holland said, I'd like to welcome you to our sixth annual Discovery Festival. So I want to just kind of talk about briefly what Discovery Festival was and what it is kind of for this year that we all find ourselves in. So normally Discovery Festival is a one-day event held at the Albuquerque Convention Center. We get about 3,000 students from across Central New Mexico who all descend on the convention center for one day of awesome STEM-related activities. And of course, STEM stands for science, technology, engineering, art, and mathematics. And so we get about 50 plus exhibitors from all over the state who participate in this event. It's amazing. The students love it, the teachers love it, and even the exhibitors love it. Now, of course, due to this COVID-19 pandemic that we all find ourselves in, of course, I'm broadcasting from home, as you see here. So due to this unfortunate pandemic, we have moved our entire Discovery Festival totally virtually. So instead of just having it for one day in November, we have it for about 3.5 weeks this year, which is pretty amazing. So we started all the way back on November the 2nd. So this is our 21st day of Discovery Festival. It's been a long one. It's been a marathon, but it's been a blast, and we hope you've gotten a lot out of it. This, of course, is our second to last day of Discovery Festival. So you still have today and tomorrow. So don't worry. We have lots of exciting exhibits coming up for you. And exactly. So we have 3.5 weeks of this Discovery Festival. And it's been a total blast. And of course, we're live streaming this out to all of our students and our teachers as you are stuck at home with all the different stay-at-home orders that have gone into effect recently here in New Mexico. That being said, I do want to quickly put together just some kind of ground rules for YouTube. So if you're watching through YouTube, first up, if anything happens, if the stream goes down for whatever reason, I don't think it will. We haven't had any problems so far in these 21 days we've been doing this. But if anything happens, if there's an interruption in the stream, a power outage, whatever, just come right back to this YouTube page. That, of course, is the BBBS CNM YouTube page. That stands for Big Brothers, Big Sisters of Central New Mexico. Go right back to this exact YouTube page, and we'll have the stream up and running shortly. Fingers crossed. I don't think anything's going to happen, but hey, want to be on the safe side. So that being said, also, please use that chat function. Please tell us where you're watching from. Let us know your school, what city you're from, all that wonderful stuff, and your questions, and we'll be sure to give you shout outs on the program. Also, this is really important. So teachers, if you are streaming this live stream inside of your Google Classroom or whatever platform you're using, and your kids have questions and they have things that they're talking about, please send us those inside that Google chat or inside that YouTube chat, because that stuff is important. We like to give shout outs. We like to read questions live on air. And we'll, again, give your class a shout out. Be a blast. The kids get to hear their names, on the live stream. So it's a lot of fun for everybody. So that being said, I do want to give a shout out, as always, to our wonderful sponsors for this event. Let's see here. So big shout out, of course, is due to our Da Vinci presenting sponsor. What you're seeing today, what you're seeing for this entire festival would not be possible without their support. So thank you so much to our Da Vinci presenting sponsor, Honeywell. Honeywell gave 2 amazing presentations about a week and a half ago. You can, of course, view those by going to our website, discoveryfestnm.org, and you can see some of the recordings of our live stream. So big shout out to Honeywell. Thank you so much, Honeywell, for your presenting sponsorship. To our Curie sponsor, Fidelity Investments. Fidelity is another one of our wonderful community partners, and Fidelity has been partnered with us for the past several years. They have this amazing 3-booth display every year at the in-person Discovery Festival, and this year they gave 2 virtual demonstrations about why save and what is credit. Even as an adult, these 2 presentations helped me quite a bit. So please, if you missed out on those, go check out our website, discoveryfestnm.org, and you can view their demonstrations. Big shout out to Fidelity. Thank you so much. To our ride sponsors, to Aztec Machine and Repair out in beautiful Bloomfield, New Mexico, and to Air Force Research Laboratories. They spoke last week on satellites, Velocity Victors. It was amazing. That was, I think, one of our most watched presentations of the festival. So big shout out to Air Force Research Laboratories for that, and Aztec Machine Repair. Thank you for your sponsorship. To our Newton sponsor, the Defense Threat Reduction Agency, or DTRA, of course, who's coming on this morning momentarily. We have Kirtland Air Force Base, we have Micronet Solutions, Sandia National Laboratories, and all of our heroes over at Presbyterian Hospitals. Thank you all so much for your support, your advocacy, and your sponsorship. Okay, let's see here. I have all these screens open, so I'm going to stop sharing that. Okay, I think that's all my announcements. Again, please use that chat function. Our presenters today are going to be sharing some awesome things inside the chat. So please stay tuned for that. Again, teachers, we're relying on you. If we share a link inside that chat, send it to your classroom. We really want as much participation as possible this morning. Whew, okay, without further ado, I talk for way too much. I'm going to introduce our presenters for this morning's live stream. We have the DTRA STEM Outreach Team. Do we have you there, DTRA STEM Outreach Team?
We're here, Will.
Awesome. Good morning. I'm going to turn it right over to you, and I'll stay tuned.
Good morning to you, Will, and good morning to everybody who's watching. Thank you so much. We're very excited to be here, and we're just going to quickly introduce ourselves and then get to the science. So hi, I'm Kayla.
I'm Chris. And I'm Jennifer. And as Will said, we are the STEM outreach team for the Defense Threat Reduction Agency, or DTRA. And we are really excited to be here to talk with you all today about research and about experimental design, which are things that maybe you have a lot of experience with already. But did you know that science is not just something that is happening in the past, that's already happened and that we're learning about in our science classes? Science is happening every single day. A lot of science is happening right there in your backyard. Were you aware that researchers at Los Alamos National Laboratory recently discovered that they could cover explosives called PETN with a polysaccharide coating? And that helped to slow the degradation of the detonator, which made that explosive last longer in storage. That's something that you're not going to find in your science textbooks. Did you know that Sandia scientists just down the road developed a self-extinguishing material that can put out sparks in solar panels and keep solar panels from setting on fire? Another thing you're not going to see in the science book. DTRA researchers are working to develop a broad spectrum antiviral medication that can combat many different viruses with just a single pill. In a situation like we have now with a pandemic, that would be extremely useful. What do all of those research topics have in common, as well as what we're going to do here today? Well, all of those researchers were using the scientific method. You know about the scientific method. I don't want to go through a ton of reminding you about it. Do you know about the scientific method? If you do, we would love to hear your thoughts in the chat. Do you know that there are steps of the scientific method that all researchers have to go through? Tell us what they are if you can remember them. Researchers have to identify a problem and then gather information in the form of research, form a hypothesis, perform their experiment, analyze their data, and use that data to draw a conclusion. We're going to try to go through an entire cycle of experimental design here with you over the next less than an hour. So we're going to start by setting up the problem. And for that, I'm going to pass it over to Chris.
Thank you, Jennifer. As Jennifer said, the first step in the scientific method and any investigation is setting up the problem. So as we got to think about what we could do virtually with you and what kind of experiment, what kind of problem we could set up with you, we had to start thinking about different aspects and different considerations with how things have changed recently. With this pandemic, we know that school has been different. Some of you were at one point maybe in a hybrid situation where you were at school and at home, and now it's all completely virtual where you're having to stay at home to do school. So things have changed quite a bit. This year has been full of these kinds of changes. So we got to thinking and wanted to investigate how stress can affect your body. How does your body react to stress? And then as we continued to think, we tried to come up with something that could be very easily measured. One of the easiest things to measure would be the heart rate. That is something that with any change in any situation, it's easy to gauge what the heart is doing. So now I would like to turn it over to Kayla to talk about the experimental design.
Thanks, Chris. So while we do know the scientific method, there are a few things that are sometimes a little difficult for us to identify and to remember. So I want to quickly talk about what we need to think about within our tests. So the first is the control. The control of an experiment, if you remember from class, is what remains or what things are like in normal situations, in normal conditions. So if we're talking about your heart rate, what is your heart rate like when you're just resting, when you're just in a resting state, not doing anything? We also have to introduce an independent variable. Now you'll remember that the independent variable is the thing that we change. It's what we're testing. We do it differently in different trials to see what reacts. That thing that reacts, that responds to the change in the independent variable is the dependent variable. It's dependent upon what happens with the independent variable. And lastly, we need to remember that we have things which are constants. If we set up an experiment and we change 5 things, how can we identify what the variables are? There are too many variables. How can we identify which of those changes is making this effect? How can we know what's causing us to have this measured change? We can't. So we have to keep everything as constant, the same as possible, except for the change of our independent variable. And then we'll measure the reaction or the response to that. All right, so let's do a little bit of refreshers with a few experiments to be able to identify control, constant, independent, and dependent variables. Jennifer?
Thanks, Kayla. Before we get started with some experiments, we need to make sure that we have our proper protective equipment on. Safety is the most important. So I'm going to put on these goggles and protect my eyes. And I want to do a little experiment that maybe some of you are familiar with already, but it's worth doing again to make sure that we can identify our variables. So I have a couple of bottles here that have some water in them. They have the same amount of water. It's been sitting here for the same amount of time. So it's approximately the same temperature. As Kayla mentioned, those are all things that we are trying to keep constant. We don't want to have differences in these bottles because then we can't tell if our experimental independent variable is actually making an effect on what we measure. So I'm going to take those 2 bottles of water and I'm going to add some bromothymol blue indicator. I'm adding the same number of drops to each one of my bottles of water. You may have used bromothymol blue indicator before in your biology classrooms. Maybe you haven't. I'm going to take this and swirl it. Bromothymol blue is an indicator, which means that it can change color to show the presence of another chemical. Right now, both of these are blue. I'm going to ask Kayla to come on in and put on her goggles so that she can protect her eyes as well. And I'm going to ask her if she can take this bottle and introduce carbon dioxide from exhaling into this solution. When she's exhaling lots of different gases, but it's a higher concentration of carbon dioxide than what is in the air. So the thing that we are changing, the thing that is different between these 2 trials is the amount of carbon dioxide in the solution. This we left exactly how it was at the beginning, our control group. And on this one, we've had Kayla exhale, introducing carbon dioxide into the solution. Thanks, Kayla. That looks pretty good. We can compare these 2 solutions now, and we can see that the one that we added carbon dioxide to has experienced a color change. The color at the end of our experiment is our dependent variable. It's what we can observe. We have blue in the control, and we've got a greenish yellow in our experimental trial. Pretty neat little experiment, right? Let's see if you can identify independent and dependent variables in another type of experiment. Come on in, Chris.
Thank you, Jennifer. Now, the second experiment requires a couple pieces of equipment. I've got a copper pipe, some PVC pipe, and here I have 2 super magnets. Now, we've got to drop these at the same time to illustrate Faraday's law. Now, as you may or may not have learned yet, Faraday's law states that whenever there's a change in the magnetic force, electricity is created. Now, with magnets, conductors help change that magnetic force and help produce electricity. So what happens when you can actually see that change? Let's find out. So Jennifer is holding these 2 pipes for me. I've got 2 super magnets, one in my left hand, one in my right. I'm going to drop them in both pipes at the same time. As I do this, watch what happens. That one came out first. That one was in the PVC pipe. Did this one come out at the same time? The one that came down the copper pipe? No, it came out slower. So in that, the independent variable is the type of material the pipe is made from. I've got PVC here. I have copper here. Copper was the conductor. So as I put the magnet down in it, the speed that the magnet came out varied according to whether it was a conductor or not. So the speed was the dependent variable. Now, Kayla's going to come in. We've saved the best experiment to last. You're going to have so much fun watching this.
Thanks, Chris. All right, so here I have 3 beakers with 3 liquids in them. The first liquid is 100 milliliters of water. The second liquid is a 50% concentration of water and 50% of isopropyl alcohol. And the third is 100%, 100 milliliters of isopropyl alcohol. I also have 3 $5 bills from the Fabulous Mall Madness game. What I'm going to do is dip a $5 bill into each of these liquids and fully saturate it with the liquid. And then I'm going to attempt to set them on fire. Now, you might be able to guess what's going to happen because I'm pretty sure you know which of these liquids is flammable and which are not. So I think you could probably make a pretty great hypothesis about what's going to happen in these two beakers. But I'm really interested to see how this 50-50 beaker works. So I'm going to attempt to do them all exactly the same, keeping as much constant as possible. I'll start with the 100% water, dip the bill in, get it nice and wet, and try to set this on fire. Right, as you may have expected, this bill, it doesn't light on fire. Set it over here. Okay, let's do the 100% isopropyl alcohol. Again, I think you can have a pretty good idea of what might happen here. I do want to do a little disclaimer. Unless you have the right conditions set up to do this experiment safely, please don't. As you know, we're dealing with flames and flammable materials. Our team has all the safety requirements set up to be able to do this safely, which you probably don't have at home. So please be careful. All right, so let's saturate this again, set it on fire, or attempt to set it on fire, and let's see what happens. Oh, yeah. So let's let it burn for a minute. I don't want to hold that in my hand because I don't want to burn my hand as well. But as you can potentially see, if you can see, not only is the $5 bill burning, the alcohol around it is burning off, but the bill itself, the paper, is also burning. It's burning up. Okay, I'm going to let that one burn out. And let's go ahead and saturate this one. Remember, this is a 50% water, 50% isopropyl alcohol. All right, let's see if it catches on fire. Ah, it does. I'm going to let it burn on the tabletop again. Now this one is behaving a little differently. I'm going to blow it out so it doesn't go too far. This one burned up, but this one did not burn up quite as much. And what's happened here is the water has protected the paper from burning. So the water soaked into the paper while the alcohol on the outside was evaporating and allowing it to burn along the outside, but not burn the paper itself. Okay, so if this is an experiment and we're trying to identify our variables, what is changed between our three trials? The concentration of alcohol. No alcohol, 50% alcohol, 100% alcohol. Okay, what was measured? What was the dependent variable? What changed amongst the different trials? Yeah, the observable fire. Did it catch on fire? Was it just the alcohol fumes on the outside that caught on fire, or did the paper catch on fire? And how quickly did it all catch on fire? Okay, so now that we really have some experience and we've reconnected with what independent and dependent variable means, we'll go back to Chris to set up our next experiment.
Thank you, Kayla. Now that you've had the refresher with identifying your variables, let's talk about what we're going to be doing today. Today, excuse me, you actually get to take part in the scientific method and gathering data and analyzing and drawing conclusions about what we do. Now, as I mentioned earlier, heart rate is a good thing to measure, and it's easy, and anyone can do it from anywhere in the world. We can do it here at the same time you're doing it in New Mexico. Now, you may be asking, why measure the heart rate? Why is that important? Several reasons. One, measuring the heart rate can tell how well your heart is working, and it can also give a general idea about your health and fitness. Every time you go to the doctor's office, one of the first things they always check is your pulse and your heart rate. They want to make sure that your heart's working correctly. If your heart is too fast or too slow, it may indicate that you have an irregular heartbeat, which is a good thing for your doctor to know. Now, depending on certain situations you may find yourself in or hormonal changes that you go through, your heart rate can change and adapt to that. And we're going to end up creating a procedure together to measure that, and Jennifer is going to go through that with you.
Thanks, Chris. All right, so Chris was telling you a little bit of background information on heart rate. And the next step of the scientific method is for us to form a hypothesis. But we can't form a hypothesis about what we think will happen until we know what our experiment's going to be. So we're going to try to develop a procedure here, and we would love to have some input from you. So whatever you can share with us in the YouTube chat would be really awesome. We want to hear your thoughts. So we need to think about how we can test to find out if your heart rate changes based on the amount of stress that you're under. We all know that we've been under a lot of different types of stress this year with the pandemic and with our school systems, like Chris was talking about at the beginning. So how can we measure the effect that that's having? Do you have any ideas? If you do, I would love for you to share them in the chat with us. What makes you feel stress? I think that I would feel a lot of stress if I were being chased by a bear. That's a super stressful situation. I'm not very fast and that bear might catch me. But that is not the type of experiment that we can run together here to see if my heart rate is changing while I'm being chased by a bear. I don't have a bear here in my office building, and I'm guessing that you don't have a bear in your house. Is there something else that we could do, some way that we could make ourselves experience stress that you can feel and I can feel here at the same time? Do you have any ideas about what that could be? I tend to be under stress whenever I'm asked to do something really quickly. That stresses me out the most. Do you remember in elementary school when you were asked to do multiplication facts quickly in front of the entire classroom? That was not something I enjoyed, and I still think I'm feeling a little bit of stress just thinking about doing that in elementary school. I think that maybe multiplication problems are a thing that we could all do together, whether you're in New Mexico or here with us in Tennessee, or whether you're watching from Virginia where DTRA is located, or somewhere else. We can all feel the stress from having to do multiplication quickly, and then we can see how that affects our heart rate. Well, let's go ahead and write a procedure for that experiment so that we can all work together on it. Kayla's going to share a screen so that you guys can see what kind of procedure we're developing. And I hope that you have some ideas so that you can feed them to us in the chat box. The first step of most experiments is to gather the materials that we need. So we're going to have to find what we need for this experiment. What do we need? We definitely need some test subjects. I'm not going to test this only on myself. That's not very valid data. I also am going to need some multiplication problems. So I'm going to gather my materials, multiplication problems and test subjects. Then in order to do the control to find out how everybody is normally, I need to gather resting heart rate of all those subjects. So I need them to rest. They shouldn't be doing anything stressful like, filming live on YouTube or anything like that. So we're going to need to have those test subjects sit and relax and be quiet for about 60 seconds. Try to get their heart rate down to resting heart rate. Once their heart rate is at resting, we'll need to measure it. So the great thing about heart rate, and one of the reasons why we chose it for this experiment, is that you can measure it at home. Do you know how to get your heart rate? You can find it in your neck. We're just going to take 2 fingers and look for our carotid artery. We're going to feel for our carotid artery. Start on your jawline, and then you can move down just a little bit. And if you press in gently, you should be able to feel a steady thump, thump of your heart rate. To collect our heart rate, we're going to count the number of beats that you feel from your artery on your fingertips in 20 seconds. I don't want to count for a whole minute. That would take a long time. But the standard unit of measure for heart rate is beats per minute. So we need to count for 20 seconds and then multiply it by 3 to get it in beats per minute. We'll record beats per minute in a data table. And now we know what our control group is. We know what our usual standard heart rate is. So let's introduce the stress. We decided that instead of having a bear chase us all, we would introduce stress by doing multiplication problems quickly. So since we rested for 60 seconds, we'll also do our multiplication for 60 seconds. And then we will repeat step 3, which was taking our pulse rate in beats per minute. Once we have the beats per minute under stress and we have the beats per minute at resting, we can compare those pulse rates to draw a conclusion. All right, there we go. We have a procedure. We're ready to go. And now you should have enough information to be able to make a hypothesis for what you think will happen. Let's talk to Kayla a little bit more about that.
Great. So now you know what the experiment is. You should know what the independent variable is, and you should be able to identify the dependent variable. Jennifer talked a lot about the control, and some of the constants are things like giving everybody the same math problems and doing it for the same amount of time. So what is the independent variable? What are we changing? What are we, the scientists, manipulating in this experiment? Usually when we write a hypothesis, we talk about the variables in an if-then statement. If, then, okay, so if we increase stress on our test subjects, then what will happen? What do you think will happen? What is your, I don't want to say it's a guess. It's not a guess. You're basing this on information that you already know. You should have some background information on your heart rate and how it's affected and how your physiological being is affected by your environment. So if you'll stop for a moment and make a hypothesis before we do this experiment. If we increase the stress of the test subjects, then what will happen? All right, I'm going to have Chris come over and talk about how we're going to gather our data for this experiment.
Thank you, Kayla. Now, since we're going to be gathering data, we need to have a place to put the data. So at this time, I'm going to ask Will if he will share the link to the Google form in the chat. This is the form that we're going to ask that you put your data into. Once you have clicked on it, once it's been entered in the chat and you've clicked on it and opened the form, it's a simple Google form. I'm sure that most of you are familiar with Google and Google Forms. This is just a quick and easy way for us to gather the data for this experiment. Now, once you open that form, it will ask you several questions. We're not going to answer them all right now, but we're going to answer some. And then as we go through the process of this experiment, we're going to answer the others. So right now, I need you to type in your school, your grade, your city, your state, and your gender. That's just basic information, just so we know where people are coming from and what area of the country, what area of New Mexico they're in. So again, your school, your grade, your city, your state, and your gender. After you've answered that basic information, I'm going to ask you to answer one more question and then stop. Add your hypothesis to the form where it asks for your hypothesis. Kayla just spoke to you about what a hypothesis is and that it's in an if-then statement form. So go ahead and enter that into the question where it says if blank, then blank. Now, stop. We've got to start collecting some data now. So for that, I'm going to ask Jennifer to come back in.
All right. You have filled out a little bit of information on our Google form, and we really appreciate that. And you might be wondering, why in the world are you asking all these questions? But we're asking you those questions because it's important as we draw conclusions to know a little bit more about our test subjects. We can't draw a broad conclusion about a lot of people if we don't have representatives in our data. So that's why we're asking you all those things. Okay, hopefully you've got a hypothesis and we're ready to get started. And you know that our first step is going to be to get our resting heart rate, so we need to all rest. So I'm going to ask Kayla to start us a 60-second timer. And I'm going to ask all of you to stop talking. Just sit down if you're standing. Take some deep breaths and see if you can get to resting heart rate. Close your eyes if you'd like to. Just don't move. Don't try to talk. We all need a little bit of this in our day, don't we? As a reminder, when the 60 seconds are over, not right now, but when they're over, we're going to use our fingers to find our pulse on our necks. We're going to count it for 20 seconds.
45.
But for now, take another big, deep breath and let it out. And just relax.
Time.
All right, that's all the relaxing you get for today. Take those 2 fingers and see if you can find your carotid artery and see if you can find your heart rate. Once you have it, we're gonna time 20 seconds. I'm gonna start the timer in 3 seconds and count down for you. Are you ready to start counting? All right, 3, 2, 1, count.
10. Stop.
All right, did you get that number? You got a number, which was the number of beats that occurred in 20 seconds. Your Google form is asking you to record it in beats per minute. So take that number and multiply it by 3 so that you get beats per minute. And please fill that number in your form. This is our control. This is the rate of your heart at resting. Now we're gonna move forward and do our experimental trial.
Great. Now that you've had a chance to relax, let's get stressed out. Here in a minute, Jennifer's going to screen share the multiplication problems for you on the screen. You're going to be able to do them perfectly. You remember your 7s, you remember your 9s, you don't need a calculator. You can do all this in your head, right? Really quickly, right? Of course you can. So we're going to put the multiplication facts up in a minute, and we're going to time you for 1 minute, 60 seconds, just the same amount of time that you had to get to your resting heart rate. And then you're going to do all these facts really quickly and accurately in your head. Then, when we're done with the 60 seconds, we'll take 3 seconds, find our artery again, and take our heart rate again. Okay, are you ready? You got this, right? All this math? No problem? It's a breeze? All right, Jennifer, go ahead and screen share those multiplication facts, please.
All right, go.
Do the math, guys. Come on. Multiply. Come on. You can do it. Get them all done. Get them right. But do all of them. Yes, all of them. Hurry up, hurry up, hurry up, hurry up. You're running out of time. You done it? You done yet? Come on. Let's go. Get them. Man, imagine if you were doing this for the whole class.
You should be halfway through.
Yeah, half time, half done. You've got half of them done? I bet you're further than that, aren't you? Come on, get them done. Hurry up, hurry up, hurry up, hurry up. I'm sure you're done by now, but keep going if not. Keep going. If you are done, just go do them again. So close, so close.
5 seconds.
Finish up, finish up.
Time.
All right, time. Stop. Stop doing the multiplication. Take your 2 fingers. Find your artery again. Identify your pulse. We're going to count again for 20 seconds, the amount of beats in 3, 2, 1, count.
Done.
All right, stop. You've got that number, the number of beats that you just had in 20 seconds. Let's remember how we get beats per minute from there to get your heart rate that we can compare it in the standard unit. We'll take that number and multiply by 3, so we get a full minute's worth of beats. Okay, now I want you to enter in that number into your Google form. You should have entered in your original number from your resting heart rate, and now you'll enter in your stress-induced heart rate into the Google form that Chris talked to you about before. Please go ahead and submit that Google form. There's a question at the bottom of it as well that asks, does your hypothesis, or does your results, your individual result, does it support your hypothesis? Yes or no? That's simple. If you said your heart rate would increase, did it? If you said your heart rate would decrease, did it? Again, go ahead and submit that Google form because we're actually going to analyze our real-time data from the data that you all have given us already. All right, so while Jennifer processes the data, Chris and I are going to do another experiment with you to talk about why we should actually do this more than once. Chris?
Thank you, Kayla. Now, as you see, I just put my goggles on so I can pull them down quickly whenever we start doing this experiment. Now, Kayla mentioned the importance of doing things multiple times. So why do we do that? Well, we want to get data that is reliable so that we can draw an appropriate conclusion about that. Now, we don't have the time to run more than one trial of data with you, but we do have lots of test subjects that we are gathering data from. But if there's time, we like to repeat the trial more than once to make sure that our data is consistent and that we have something that we can validly conclude. Now, this experiment is going to take 2 people. So that is why Kayla has joined me here. Now, as you see, there are 3 beakers here. Each of these beakers has the same amount of vinegar, 50 milliliters in it.
Right, so this is an experiment that you're familiar with. We've got vinegar, we've got baking soda. You've seen this? Yes, it's going to release carbon dioxide. Yes, it's going to bubble. No, we're not blowing up a balloon. We're going to do something a little different with it. We're going to check to see if this is an endothermic or an exothermic reaction. So that means, is it absorbing heat to create the reaction, or is the reaction giving off heat? So in order to do that, we're going to add a ½ teaspoon to each of these beakers. We're not changing anything here. What we're doing is repeating the same trial over and over again to validate our results. Okay, what if something goes wrong? Is one time enough? It's not. If we want really good conclusive results, we need to repeat a trial. So what we'll do is Chris is going to go ahead and put a temperature probe into the vinegar here. And he's going to get us the temperature of the liquid. We're going to run the experiment, and then we'll check the change of the temperature in 15-second increments. We'll take our starting temperature and our final temperature, and then we'll compare them throughout our trials.
Now, to gather this information, we are using a LabQuest 2 with a temperature probe in it, which gives us real-time temperature readings. Now, the temperature of the liquid that we're starting with is 21.4 degrees Celsius. So that's just the standard temperature of this first beaker before we add baking soda to it. Now, Kayla's going to add 2.5 milliliters of baking soda to the solution, and then we're going to take the temperature after that. So Kayla, if you want to go ahead and add that.
All right, Chris, I'm just going to stir it to make sure that we get a full reaction.
That sounds good. We're going to do this for 15 seconds, and then we're going to take the ending temperature after that. So we're at 10, 11, 13, 14, and we're at 16.8. So the first beaker temperature actually reduced to 16.8 degrees Celsius. Now I am going to prepare things for the second beaker.
Yeah, so the reason that Chris is changing the probe here is because this probe has now been used. It's now not at resting temperature. And so we want to, if available, change the probe out. We could also just wait for the probe to go back to normal temperature, to air room temperature, but we have enough probes to try it again. So let's just put a fresh probe in. Okay.
Okay, the starting temperature of this probe is, again, 21.4 degrees Celsius. So it is the same as the starting temperature for beaker 1. We're going to repeat the same thing, doing the exact same timing so that everything is identical.
There you go.
Okay, so Kayla has put in 2.5 milliliters of baking soda. We are going to give it 15 seconds, and then we're going to take the ending temperature of this beaker. So at 15 seconds, we are at 16.8 degrees Celsius. You guys notice anything yet? Okay. And again, I am going to change the probe so that there is a brand new, not used probe with this. It has not been submerged in anything. And again, I'm going to place the probe in the beaker. I'm going to get the current temperature of the liquid that is in there. And this one looks like it is at 21.6 degrees Celsius. So slightly warmer but still around the same temperature as the first two beakers. And again, Kayla's going to put 2.5 milliliters of baking soda in the beaker, and we're going to measure. Okay, so this one is going. This one is at 17.0. So still close to what we had before. So now we have run the same exact test 3 times with the exact same conditions.
Right. So let's talk about that for a second, Chris. I could do more trials, and actually, when we tested this before, right now, we needed to do more trials. We did 4 and 5 because we didn't have quite precise results as we do now. If you look at our results, you can see that our temperature change, even though we started at a slightly different temperature here on trial 3, our temperature change is still the same. So at this point, I can feel pretty confident to say that yes, this is an endothermic reaction. Endothermic meaning that the reaction pulls heat from I'll say its environment, but from the materials in order to cause the reaction to happen. That means that the temperature of the liquid is getting cooler because the heat energy is actually going into the reaction. All right, not only can I say that this is pretty conclusively an endothermic reaction, I can also say that the temperature change amongst our 3 trials show that it's the same. We have the same change in temperature between each of our 3 trials. So I don't feel like I need to repeat this one at all. So let's talk about what this means for our experiment, for the heart rate experiment. In the heart rate experiment, we asked each of you to do how many trials? Now, that's kind of a trick question. We asked you to do a control trial, and then we asked you to do an experimental trial. So we asked you to do control with a resting heartbeat, and then we asked you to do the same thing under stress. So I asked each of you to do 1 set of the trial. If I really wanted to do a great job of this, I would ask each of you to take that same data, both the resting and the stress data, multiple times to be able to check and see, is your heart rate changing, both either increasing, decreasing, or remaining the same, and is it doing it at the same rate each time? We don't really have that capability within the constraints that we are trying to conduct an experiment over YouTube live with students in a completely different place in the country. So instead, we're hopeful that we have a large enough pool of test subjects that we can do 1 trial with each of our test subjects, but we have a large pool of male, female, of 9th graders, of 12th graders. It's similar to how they do, if you've been listening to the news, how they've been doing the vaccine trials. They only do that once with each person, right? But if they have enough people, then they have a large enough group to pull the data from to still find the trends in the data. So now Jennifer is going to talk to you about the data.
All right, thanks, Kayla. I appreciate it. We are about to share with you in the chat. We are about to share with you a link that's going to allow you to access the data that we have just collected from you. So as soon as Will shares that in the chat, you can click that and you're going to see a spreadsheet. I don't know about you, but I love spreadsheets. I hope you do too. And I'm hopefully going to get this spreadsheet shared on my screen with you so you can check it out. If you click that link, you'll have access to this spreadsheet data, which means that you can play with it. You can look at it. You can do what you want to do with it. We've purposefully not asked any of you for any identifying information so that we can look at each other's data and draw some conclusions without worrying about inadvertently sharing information that people wouldn't want to share. So as you can see here, we have quite a few of you who have participated with us here today. We're really thankful to you for that. We've got about 14 people in our spreadsheet here, most of whom are from Albuquerque, but we've got a little bit of different places represented here. And you can see everyone's resting heart rate here in column G. And you can see their heart rate under stress here in column H. I'd like to do a little bit of analysis of this data, which means that we need to compare the data for your heart rate under stress to your heart rate not under stress. So to do that, this spreadsheet has a lot of really awesome tools that'll let you do that in some ways that are easier than with paper and pencil. So I can come up here to column H and I can insert a column to the right and make my own new blank column, which is going to be the difference in my heart rates, the change in my heart rates. I'd like to type that there so that I have a header for this column. And instead of me going through and doing a bunch of math, which might cause me to be stressed out doing it in front of all of you all quickly, I can put a formula in. So the great thing about spreadsheets is that I can hit equals and tell this I'd like to subtract 90 minus 72, which was someone's heart rate under stress and their resting heart rate, and hit enter. And it's going to do the math for me. And then it asks me, would you like to autofill? Would you like to do this to everything? Yeah, I would. I don't want to type that formula over and over and over. So now I can see everybody's change in heart rate. And this is really cool, but I can't get a lot from this without doing a little bit more analysis. So I'm going to sort this. By clicking this square up here in the corner, I can select my entire spreadsheet. And then I can go over here to my data and click sort range. In this case, I'm going to sort this by my difference in heart rate, which I put in column I. Here's my difference in heart rates. And I want it to sort so that it puts them in order. I can see that there are 2 of you out there watching whose heart rate actually decreased, which was not what most of you expected in your hypothesis. There's 1 of you out there whose heart rate didn't do anything at all. It kept beating, but it didn't change in our stressful situation. I wonder if that person's really good at multiplication. And then you can see that I've got 11 of you out there whose heart rate did increase, which is what most of you thought would happen in the hypothesis. We can take that information and we can use it to draw a conclusion. But I'd like to represent it in a graph so that we can really understand what's going on. Spreadsheets in general have some really awesome ability to create graphs and tables. And if we had a lot more time, I'd like to be able to show you how to do that. But I don't have enough time to show you exactly how to do it. So we're hopefully going to have one of these spreadsheets or one of these charts pop up here for us in just a minute. Technical difficulties are always fun. All right. Well, we're going to go ahead and bring Kayla in here to talk about this chart while we try to get it shared.
Chris is going to talk about the chart while I share it on the computer.
Yes. So as Jennifer mentioned, we have a few technical difficulties, but it's something very simple. Kayla's going to get the chart pulled up, but let's talk about why charts are important whenever you're dealing with data and when you're graphing information. Using graphs and using charts are a very easy way to visualize all of the numerical data and all the numbers that you gathered. So Jennifer had a spreadsheet with a lot of different people with a lot of different numbers in it. Now, the great thing about spreadsheets is they can take that information and create a graph out of that so that you can easily see things and easily draw conclusions about that. So, Kayla, do you have it pulled up?
It's up.
Great. So right now, all of you should be seeing a pie chart. Now, that pie chart has 3 different colors in it. There's a green, there's a red, and there's a gray. Now, those pieces indicate the different categories that we had. Some of you had your heart rate increase. Some of you had your heart rate decrease. One of you had no change whatsoever. Each piece of that pie represents one of those conditions. Now, what can you see from that chart? What conclusion can you draw by seeing the pieces of that pie chart? Looking at it, it is very easy to see that most of you had your heart rate increase. Now, that is a conclusion we can draw that under stress, under the stress of doing multiplication problems, that the heart rate will go up. Now, I'm going to ask Jennifer to come back in to do a quick wrap up.
Hey, thanks, Chris. I really hope that you guys enjoyed doing that with us. I hope that you had a good time walking through the process of doing an experiment and designing an experiment. As I mentioned at the beginning, that process is the same process that scientists and researchers all over, including the DTRA scientists that we represent, do every single day to help solve much larger problems. If you enjoyed that, if you're interested in doing STEM research projects like this and even more complicated STEM research projects, DTRA has an incredible summer program for high school students called the Joint Science and Technology Institute.
So each summer, we bring students from all over the country, actually to your state, to Albuquerque, to UNM, to do research for 2 weeks with scientists from all over, scientists from DTRA, from LANL, from Sandia, from all sorts of professional science, or they're all professional scientists who don't do experiments like vinegar and baking soda with you. They do things like PCR and manipulation of genes and building of robotics, 3D printing, telemetry, biology, all kinds of great in-depth science experiments that you can do with professional scientists. And the best part about these programs is that they're completely free to you.
If you're interested in going somewhere a little bit farther and you don't want to stay in Albuquerque for a summer STEM program, DTRA also sponsors a JSTI that takes place in Maryland. So yeah, we'll fly you across the country from your home in New Mexico to Maryland so that you can do research there with DTRA scientists and other experts in the field. We would absolutely love to have you join us for those. So if you're interested in that, we're going to be sharing a couple of links in the YouTube chat, one for the program that takes place in Albuquerque, and one for the program that takes place in Maryland. If you'd like to receive an application whenever those open later on this winter, just put in your name and email address and we'll send one straight to you so that you can apply for DTRA's free STEM research program this summer.
But what if they want to apply for both, Jennifer?
I mean, I guess they could apply for both. You could even be selected for both, but you'll have to choose only one to attend.
Great. And teachers, listen up. We have a program for you as well. High school teachers also can come to both programs, the one in New Mexico or the one in Maryland, and do 2 weeks of research. And your research is in small group or one-on-one with mentors, and you are almost always in their laboratory. You get to go on to Aberdeen Proving Ground. You may go into LANL and work for 2 weeks with a professional scientist to do research. Not to come and teach students, but you get to come as a learner to get your hands back into that science that you love, that you get to share with your students now.
It's a really great opportunity for both students and teachers. So we hope to see a lot of your names come through and your applications come later on in 2021. We would like to thank all of you for joining us here today for our experiment. We really appreciate it. We hope you enjoyed it. We'd like to thank the Discovery Festival for hosting us once again, and we hope that you all have a great day. Thank you.
Great. Thank you so much, DTRA STEM outreach team. That was fantastic as always. Whenever we get out of those presentations, I'm like all energized and ready to go for the day. So a big shout out to DTRA and their wonderful STEM outreach team for being with us at this Discovery Festival. Please, students and teachers, we did share those links inside the chat. So teachers, if there's any students that come to mind when they were talking about these amazing summer programs, please be sure to share those links with them. I know that they would love to see some students from here in New Mexico represented at those amazing, amazing programs. So again, yeah, I'm just so amped about that. And I do, of course, as always, want to just give a final shout out as we wrap up today. I'll put this screen up while I do my closing announcements, but a big shout out, to our presenting sponsor, Honeywell, to Fidelity Investments, our Curie sponsor for this event, Aztec Machine and Repair, AFRL, Air Force Research Laboratories, the Defense Threat Reduction Agency, DTRA, who you just saw present today, to Kirtland Air Force Base, Micronet Solutions, Sandia National Laboratories, and all of our heroes at Presbyterian Hospitals. I do also want to give I want to share a little bit here about some other presentations we have today. So at 11 a.m., in just about half an hour, we have Kirtland Air Force Base, the 377th Air Wing Division is coming on today at 11 a.m. So look forward to that. Come back if you want to hear about the amazing things that they do at Kirtland Air Force Base. At 1 p.m. today, we have Central New Mexico Community College. CNM is going to be talking about recruitment at 1 p.m. today. Tomorrow at 9:30 a.m., we also have Central New Mexico Community College coming back on to talk more about recruitment, some of the programs they offer. This is a new one, actually. So tomorrow at 11 a.m., this is new. We talked about LANL at the end of today's program. And LANL, of course, is Los Alamos National Laboratories. So we just got confirmation this morning that they're going to join us tomorrow on our final day of Discovery Festival at 11 a.m. So please be sure to check that out. And then at 1 p.m. to wrap up the whole festival, we have Arizona State University, the Ira A. Fulton Schools of Engineering going to be talking about their program. So this would be great for any high school students who might want to consider Arizona State University engineering programs for their future. Otherwise, hey, everyone, stay healthy, stay safe, and we'll see you in about half an hour as we get ready to welcome Kirtland Air Force Base. See you guys then.